Welcome to Math Challenge 444. In Math Challenge 444, we have an equilateral triangle and a red semicircle. An equilateral triangle and a red semicircle as shown. Radius of the semicircle is 10 and we have to find the side of equilateral triangle. We have to find each side of the equilateral triangle if the radius of the semicircle is 10 units. Math challenge for all quantitative and numerical aptitude tests. Math challenge 444. Now let each side of the equilateral triangle be A. Let A be the side of the equilateral triangle. So area of the equilateral triangle is given by root 3 into side square by 4. So A is the side of the equilateral triangle. A is the length of each side. Then the area will be root 3a square by 4. Now you can also derive the area thus. S semi-perimeter will be equal to A plus A plus A. All the three sides are equal by 2, that is 3a by 2. So using S into S minus A into S minus B into S minus C, you will get the same result, root 3a square by 4. Even if you did not know the formula for equilateral triangle, you can solve using Heron's formula. So the area for equilateral triangle with side A will be root 3a square by 4. Now draw the perpendicular. You can see the blinking line. Draw the perpendicular bisector from vertex to base. Now because it is equilateral triangle, this perpendicular bisector will divide the triangle into two equal right angle triangles. The perpendicular line which you can see blinking will be dividing this whole triangle into two equal right angle triangles. This can happen only in case of equilateral and isosceles triangle. So here we have an equilateral triangle. So this blinking line divides it into two equal triangles, each of which would be a right angle triangle. So we get two equal areas. The triangle has been divided into two triangles of equal areas. So you can see that what we are doing, we are drawing the two radii. From the center, we are drawing the two radii to the sides. The sides are actually the tangents. The left side and the right side of the triangle are tangents. So we are drawing the radii, and remember that radius is perpendicular to the tangent. So the white line, you can see the animation. We are drawing the radius from the center to the tangent, or from the center to the sides of the triangle. Now tangent is always perpendicular to radius and radius is always perpendicular to tangent. One half of the equilateral triangle, if you take only one half, what you will find? The base is the side of the equilateral triangle, that is equal to A, and the altitude is a radius R, the white line. The white line which is a radius, that is R, the altitude, and the side of the triangle, that is A, that is the base. Take only one half, one right angle triangle. So for each of them, area will be equal to half into base into altitude, that is half into A into R, but radius is given 10. A radius is given 10, so half into A into 10, that is 5A. That is for each half. So the left half and the right half, each area will be equal to 5A, so the total will be equal to 10A. For each half, the side is a base and the altitude is a radius. So half into base into altitude, that is half into A into R. Radius is 10, so we get 5A. So each of the right angle triangles, the area 5A. So the full triangle area is 10A. And this 10A is equal to this area root 3A square by 4. So write root 3a square by 4 equal to 10a, because both of them are representing the area of the equilateral triangle. So equate them, divide by a, because a is not 0. A is not 0, so we can divide by a. So root 3a square by 4, a square will become a if you divide by a, root 3a by 4, and 10a if you divide by a, it will become 10. So root 3a by 4 equal to 10. A is equal to 10 into 4 by root 3, that is 40 by root 3. And if you rationalize the denominator by multiplying numerator and denominator by root 3, 40 into root 3, 40 root 3, in the denominator root 3 into root 3, 3. So 40 root 3 by 3, which will give you 23.1 approximately. We are equating the area of the equilateral triangle obtained by two different methods. Root 3a square by 4 equal to 10a, and divide by a. So root 3a by 4 equal to 10, or a equal to 10 into 4 by root 3, or 40 by root 3, and multiplying numerator and denominator by root 3 for rationalizing, we get 40 root 3 by 3, or 23.1 as the side of the equilateral triangle, and that was the solution. Each side of the equilateral triangle will be approximately 23.1.